Hi, and welcome to this introduction to the Micronaut MuShop application. My name is Graham Roche, and I'm going to be taking you through a brief introduction to Micronaut for those of you who haven't heard of it. Micronaut is a relatively new Java application framework for building microservice and serverless applications that takes a different approach to traditional applications by using the annotation processing infrastructure of Java to hook into your Java compilation process and eliminate the need for things like reflection, runtime proxies, and runtime bytecode generation completely, which makes it a great fit for GraalVM native image since it can easily perform a closed-world static analysis on the Micronaut application. To find out more, head over to the website, check out the documentation, generate an application today with Micronaut Launch, or get a full overview of Micronaut at the link at the bottom of the slide. So let's talk about the original Oracle Cloud MuShop application then. The original Oracle Cloud MuShop application is a reference application that is built in a variety of different languages in order to showcase using Oracle Cloud services. So it's intentionally a polyglot application where you have different backend microservices written in Go, written in TypeScript, written in Java, composed into a set of microservices and running on Kubernetes on Oracle Cloud infrastructure. The Micronaut MuShop, on the other hand, has taken all of these applications and rewritten them in Micronaut in order to provide a showcase of best practices for building Java applications, running them on GraalVM in a microservice environment, and running them on Kubernetes on Oracle Cloud. In addition, the entire showcase is deployable to Amazon Web Services as well, AWS, at a simple click of a button. So it's a great example of how to build and how to construct a suite of microservices that are deployable to your Kubernetes infrastructure. And we're going to have a look at some of the code today and some of the benefits of using Micronaut and GraalVM to build these applications. So let's go through some of that code then. Over here I have the original Oracle Cloud MuShop application sources, and we're going to look at the catalog application first, which is written in Go, in the Go language. And you can see with the Go implementation, there is a lot of manual SQL munging. So it's what I call manual SQL munging, where you essentially have to use string concatenation to accumulate a query, munge it together and execute it manually, opening and closing connections, and implementing a lot of very error-prone, error handling logic. All of this goes away with the Micronaut version. So if we look at the Micronaut version of the same thing, everything is essentially encapsulated in what's called a repository. So all of those queries are simply declarative interface methods that you declare in your code that get implemented at compilation time for you and translated into the appropriate SQL query in a completely type-safe and secure manner, which is really nice. In addition to that, the Go application has essentially, and most of the applications in the original Oracle Cloud MuShop have a manual API, Open API definition, which describes how the API works. And in fact, a lot of these Open API definitions have become out of sync over time with what is actually implemented in the service. One of the nice things about Micronaut is if you look at many of the controllers, for example, you will see that Micronaut will actually take the result of your java.comments and at compilation time produce automatically a Swagger / Open API definition from your code, from your source code, from your Java source code. So it never becomes out of sync with what is actually in your service. So this is really nice because you only have to write your comments in one place, and the output of your Open API definition reflects that. And then when you deploy into production, like we have done here, all of those Java.comments end up in your generated Swagger, and the API stays consistent with what is actually in the code, which is really important. In addition to that, there's a number of important differences with and improvements to the way, for example, even Java versus Java. If you look at the original MuShop application, and for example, the orders Spring application here, you'll see that the Spring application uses a kind of messaging service implementation to communicate with NATS, the NATS messaging stack. And a lot of this is manually implemented, manually management of the NATS and dispatch of messages and marshalling of everything. It all results in a lot of additional code for the Spring implementation. Whilst on the Micronaut side, if we look at the same implementation, the whole all of that code is simply encapsulated by a single annotation on interface. So you put @nats client on the auto publish interface and define methods that you want to publish to particular subjects, and all of the plumbing work is implemented for you by Micronaut automatically. Nothing left to do from a developer perspective, which greatly improves reliability, productivity, and many different aspects. In addition to that, you'll notice that in traditional frameworks like Spring and so forth, there's a lot of like URI variables inside annotations that you see that reference, for example, parameters. And many of these, if you, for example, declare the wrong value here, can result in an error at runtime, or do result in an error at runtime. But this is not the case with Micronaut. So, for example, if I were to name this oid, and I don't rename that parameter here, you can see that I get a nice error at compilation time from the IDE saying the route declares a URI variable named order ID, but no corresponding method argument is present. So to actually correct that, I actually have to go in and rename that URI variable in order for my application code to compile. And that's really critical for developer productivity, that good errors are manifested in framework level in strings that are not as type safe. And that kind of validation we can do with Micronaut because we process everything during compilation time. In addition to that, another huge benefit of Micronaut is how everything is uniformly handled. So if you look at cloud native, so for example, if we look at the resources directory here, you'll find many different configuration files which are based on Micronaut's cloud native configuration. So you'll see that Micronaut will actually automatically detect and know when it's running in the Amazon environment or whether it's running in the Oracle Cloud environment, and load the appropriate configuration file for you, which means in practice you can expose cloud native configuration. For example, here we're exporting metrics uniformly across the whole application to Oracle Cloud. We're using Oracle Cloud Instance Principles. We're using Autonomous Database, Oracle Database in the cloud. We're exporting traces to Zipkin and Oracle Cloud Application Performance Monitoring. And all of that is declared simply and succinctly in cloud native configuration, which is not loaded when you're running in the AWS environment. So in the AWS environment, we export metrics to CloudWatch instead, and we use MySQL database instead, and basically Redis for sessions instead. And essentially, that means that we can adapt the application's behavior to different clouds just through native cloud native configuration, which is pretty damn awesome. Okay, let's move on to the next part of the demo, which is how to deploy Micronaut MuShop to Oracle Cloud. So if you follow the instructions here, there is a very convenient deploy to Oracle Cloud button. Now it gives you some options. You have to accept the terms. You can essentially choose whether you want to deploy with Oracle Function and Oracle Streaming Service and send traces via Zipkin if you want to. And then you should, of course, make sure that you apply the stack once you're done. But basically, it's just a matter of clicking the Deploy to Oracle Cloud button, accepting the terms of use, which will load the stack information. You can leave everything else as default. Then you can come in here and optionally create, like I said, the different parts of the application for example, sending a newsletter or event streaming or Zipkin tracing, etc. I'm going to leave those off for now. And click next, and then make sure you click run apply and click the create button, and that will create using Terraform, the stack to deploy your application. Now this process will take some time, so we'll let it do its thing and get back to it when it's done. Okay, so once your Terraform plan has completed, you can head over to the successfully completed Terraform plan and look at the outputs on the left-hand side here. And you'll see there are some various different outputs. And the key one that you want to be looking for is the MuShop URL. So you can copy that and then paste it into your browser, and MuShop is up and running on Oracle Cloud, and you can find out about it in the About with all the information on the composition of the stack and the different applications in the About tab. Okay, now we're going to move on to the next part of the demo, which is deploying to Amazon Web Services. So once again, we provided really convenient documentation explaining how to do so in the MuShop docs. But more or less, it's a matter of clicking the Launch Stack button, clicking Next on the Create Stack screen, leaving all those defaults as is. And then what you want to do is you want to make sure that you have at least 3 availability zones set. And you want to make sure that you have an SSH key that you can use to deploy, key pair setup, which is explained in the docs. And then you can click Next, and then Next again, review the final screen, and click Create Stack. Oh, we probably should acknowledge. Yes, I acknowledge the terms and conditions. I acknowledge those 2 things, and then we create the stack. So it'll take a little while, once again, with AWS to actually create the stack. So we will get back to this once it's complete. Okay, so once complete the CloudFormation stack, we will have your Micronaut MuShop, which will have a variety of outputs. And one of those outputs will be the address to the deployed instance of MuShop on AWS, which you can open up in another tab and browse the deployed application. And there it is running on AWS as well. So simple as that. So in summary then, as you can see, Micronaut GraalVM and Oracle Cloud provide a robust modern architecture for building cloud-native applications. With what you get with Micronaut MuShop is a comprehensive showcase application on how to do that and how to deploy it to both Oracle Cloud and Amazon Web Services. You can find out more with the documentation at the link below. And do check out the source code as well on GitHub. And I hope you enjoyed this presentation.